Hello, and welcome to the discussion on the thermal equator. So, a thermal equator is really simple. This is where we find the highest mean temperature at different locations on the Earth, and we plot the point where the highest mean temperature occurred and where these temperatures are connected. These points are connected. You get a line, an isotherm. So we're going to follow the thermal equator. So what will that happen as the shifting of our Earth's heating system changes and so forth? So in review, we're going to think about our insolation map, intercepted solar radiation, and how during our equinoxes and around those seasons, the fall and spring equinoxes, the Hadley cells are around the equator. But what happens during our solstices, right? So what we've studied so far is that the warm Earth leads to warm air that rises, cools, and makes clouds and rain, making the intertropical convergence zone. And then around 20 to 35 degrees north and south, we get the subtropical high pressures, and this feeds back in toward the equator, the ITCZ. So these Hadley cells are simple enough to understand when we look at the equinoxes, but what happens when the shifting of the Earth's heating moves toward the solstices times of year? So we see during June 21st and the couple months before and after, the greatest heating of our planet is in the northern hemisphere, the Tropic of Cancer, 23.5 degrees north. So that whole system that we talked about heating at the equator now shifts its Hadley cells into the northern hemisphere dominant. And then during the winter months for you and I, the greatest heating of the Earth is at 23.5 degrees south and in the southern hemisphere, shifting everything south of the equator. So we'll look at some slides here to think about that. There we go. So we see the greatest effects of the thermal equator shift to the south is over land. And that's wonderful because that helps us to understand another concept between land and water heating differences. So if we come back to that map, you can think about whether you're looking at winter months or summer months and what evidence you have for that. Well, we can see the shift has gone to the south because the heating of the Earth has moved into the southern hemisphere. And it's most extreme over land and more moderate over the water. So we learned that must be January, December, February as we shift into our winter months and the southern hemisphere's summer. So let's think about these facts that we saw on the January map. Right? We know that during that time of year, radiation is approaching 23.5 degrees south. The northern hemisphere has shorter days and longer nights, cooler temperatures. And so we see that the thermal equator shifts to the south and the effects are much greater over land than water. So if this map didn't say July, what would be your evidence that we've moved into summer months in the northern hemisphere? Yep, sure enough, you can see, especially over land, that the heating of the Earth has shifted into the northern hemisphere. And we know that our summer solstice, our most direct radiation, is located at the 23.5 degrees north, Tropic of Cancer, and we can see the extremeness over land and water land versus water once again. So let's think about what we're dealing with when it comes to land versus water. A concept that will be very important for the rest of the semester is understanding hidden heat, latent heat. That polar water molecule that we'll be studying stores energy. It's hidden within the water molecule. Then this energy can be released or absorbed. Well, we're looking at land over here, where the heating of the earth occurs very rapidly, but to shallow depths. So if you imagine kicking off your flip-flops and walking on this hot beach, you're like, ow, 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 till you dig your feet down a couple inches, and it's nice and cool again. This is because the earth's surface, land, is opaque, right? Well, the transparent nature of water requires heating to go to much greater depths, making greater volumes of material to be heated. And so we say that water has the ability to store more energy, a higher specific heat capacity. It's like a bank for energy. While land heats up rapidly and cools down rapidly, water doesn't do so. And so it cools down slowly, but it also heats up slowly. And so we call water the great moderator because it can absorb energy and it can release energy to moderate conditions, while land provides more extreme scenarios. So these patterns we've observed are due to the heating differences between the solstices and the equinoxes, shifting the thermal equator, and what we're going to see now, shifting the intertropical convergence zone, which means rain and all the patterns that we see across the earth. We also were able to see the big differences between land and water. So what we'll go into after you're done quizzing yourself on this material, right, is we're going to go next into why is there such a large high pressure system here? Well, we see in January the intertropical convergence zone following the thermal equator takes clouds and rain in the low pressure systems southward, leaving a high pressure system sitting massively over Eurasia. Notice how weak the system is here off of West Africa, how weak it is over the west coast, and how strong this low pressure clouds and rain system is on our coastline. So this shifting to the south should indicate to you winter months for the northern hemisphere. Now look at what actually happens in July. That high pressure system is gone. And instead we have the extreme opposite, rising low pressures, clouds, and rain. So this area that was being torpedoed by dryness and drought and high pressures has now just drastically changed to the intertropical convergence zone being overhead, clouds and rain. Notice this high pressure system that was small before is now big and dominant and large over the Atlantic Ocean, feeding the hurricane systems that we'll study some more of. And we can see that that low pressure system that was bringing us rain in our winter months now brings us the beautiful California sunny summer skies. Right? So we know these are the northern hemisphere summer months. So go ahead and take that material, recreate it into your own words, and take a quiz to figure out how well you learned that material. All right.